Paper 1, 2017. Question 9.2. So I've got carbon monoxide, 2 moles of hydrogen making 1 mole of methanol. At the start, there's 20.1 moles of carbon monoxide. According to the question, 24.2 moles of hydrogen, no moles of methanol. At the end, at the equilibrium, it says there's 2.16 moles of methanol. Well, 1 mole of carbon monoxide makes 1 mole of methanol, so 2.16 moles of carbon monoxide must be used up to make the 2.16 moles of methanol. 2 moles of hydrogen react for every 1 mole of carbon monoxide, so multiply the 2.16 by 2, 4.32 moles of hydrogen are used up. Let's calculate how much is left at the end. 20.1 of carbon monoxide at the beginning, 2.16 used up. 17.94, but I've put it to 3 significant figures because all the data in the questions, 3 significant figures, 17.9. Hydrogen 24.2, 4.32 used up. 19.88 or 19.9 to 3 significant figures, and the methanol is easy, we've just made 2.16, it tells you that in the question. Moles of carbon monoxide 17.9, moles of hydrogen 19.9. A different mixture of carbon monoxide and hydrogen was allowed to reach equilibrium. (600 Kelvin). In equilibrium, the mixture contains 2.76 moles of carbon monoxide, 4.51 moles of hydrogen, and 0.36 moles of methanol. Total pressure was 630 kilopascal. The 600 Kelvin, by the way, is a red herring. We don't need that at all. I'll write a Kp. Kp is the partial pressure of the methanol divided by the partial pressure of carbon monoxide multiplied by the partial pressure of hydrogen to the power 3. Why to the power 3? Because this should be to the power 2. Because there's 2 moles of hydrogen in the equation. Partial pressure of methanol divided by the partial pressure of carbon monoxide multiplied by the partial pressure of hydrogen squared. Now I need to add up the total moles of gas, 2.76, 4.51 and 0.36 rather. 7.63 moles in total. I need to scale that down to 1 so I can work out something called mole fraction. So I need to divide everything by 7.63. 2.76 divided by 7.63, 0.362. Mole fraction of hydrogen, 4.51 divided by 7.63, 0.613. Methanol mole fraction, 0.36 divided by 7.63, 0.0472. So they're the fractions of 1 mole. 1 mole of the gas creates a pressure of 630 kilopascal. I need to work out how much each of the gases contribute to that pressure. So I'll multiply the total pressure by the fraction of gas. Partial pressure of carbon monoxide, 0.362, that's the mole fraction, multiplied by the total pressure, 632.28. Do the same for the hydrogen, 0.613 times 630 is 372. Partial pressure of methanol, 0.0472 is the mole fraction, multiplied by 630, 29.7. Now plug all the numbers into the Kp expression. Work it all out. The Kp is 9.41 times 10 to the minus 7. And I've put it to 3 significant figures because everything else is to 3 significant figures. Units. Well, I've got 1 pressure on top, partial pressure of the methanol, divided by the partial pressure of the carbon monoxide multiplied by the partial pressure of the hydrogen squared. So I've got 1 kilopascal on the top, 3 kilopascal on the bottom, cancel a kilopascal top and bottom. I've got kilopascal squared on the bottom, which is kilopascal to the minus 2.